Okay, today's task is 863, all nodes distance k in a binary tree. Let me open drawing tool. Let me move this. So we have basically the problem statement is the following. We have a binary tree and we have a target node, and we should find all the nodes that are at k distance from a target. So in this case, if you go like if the k is equals if the k equals 2, so the distance 1 gonna be 3, 6, 2 from 5. The distance 2 from 5 gonna be 7, 4. Like there are 2 hops and 1 going through the parent element of the 5 and actually through the root. So the output should be 7, 4, 1. So generally there are two ways. There are two ways how, at least that's how I plan to solve this problem. So the first idea is convert binary tree to graph and do DFS or BFS for from target to find all children or like all nodes at the distance k. So the second idea that I probably gonna implement right now is have like parents hash map, parent mapping. Let's say we have node, and for every node except root, you're gonna have parent mapping. So in this case, for the 5, the parent gonna be 3. For the, let's say, for the 3, the parent gonna be null because it's root. And let's say for the 0, parent gonna be 1, so on and so forth. So the first step in the second approach is to find the parents that are for the nodes we care, and the second step here is like I start from the 5 and I go both ways. I go up and I go down. So let's say I'll call the function find nodes, and we call it find nodes at distance k, and we call it like save for the node. And for the 5 children, I call find node so we have initially k equals 2, so I call find node k equals like k minus 1, and this one gonna be equals 2 for the node for the children 6, and I call to find the node k minus 1 for the child 2, and then I'll also pass the variable basically from where I call this find node. So I call it from 5, and here let's say I call it also from 5. And there was first time like first, let's say A call, B call, and then C call gonna be, I'm gonna find the parent for the 5, and I will call find. So the parent for the 5 is actually 3. So I'll call find node key minus 1 for the node 3, and I am coming from node 5. So why I'm giving this from node? So basically, I go like at best from the target. I go 3 directions, and then all the following I either go 1 direction or 2 directions. So let me illustrate this one. So we have this tree. So initially I go 3 directions. So I go call the find node k minus 1 here for the 6. I call then it for the 2, and then I call it for the 3 for the parent for the 3. And then when I gonna iterate, and then like all next step, go to step A for node decrement k. Okay. So like here, like it was k equals so now like initially k was equals 2, k was equal 2, then now k is equal 1 here, k is equal 1 here, k is equal 1 here. So we have like one step left. I need to do one more hop, and to do so, I need for, let's say we take 3, and we need to go whatever direction is available except the from. So we came from 5, and 3 has 2 children and no parent. So 3, we check that we came from 5, so we don't want to go there again to disallow re repeated like nodes in our output. So I go additional step to the right because 1 is not equal 5. It's like node 1 is not equal children node is not equal to the node we came from. Um, so I go to 1, and k in this case is gonna equal 0. And because I cannot k is equal 0, it means that the current node should be added to the output. So accumulator, let's say, gonna be 1. I'm gonna add the 1 to accumulator. And then for the 6, can I go further? No. I came from 5, but I cannot go to the parent. I can only go to children, but both children are null, so I just exit. And for the 2, I check if I can go to the parent. No, I came it from, I pass the node from, and like 5 equals to the node from when I stay at node 2, so I can go maximum to children elements, so to 7 and to 4. And in this case, k gonna be equal 0, k gonna be equal 0, and I add 7 and 4 nodes to the accumulator output, and this gonna be result. Yeah, so the time complexity for this one. So first time I need to go to basically save this child parent mapping. And I only need to do that for the upper node as soon as I meet the target. Um, I don't need to like I only need to go to the parent until I reach the target. So child to parent, so it's gonna be at worst of n, and then I need so that this time complexity of n as of now, a space complexity. I need to save this mapping, and at worst it's gonna be O of n also, and time complexity of n, and then the second stage when I need to traverse again the graph to find the k. So at worst we're gonna have k equal to the like max diameter of the graph, of the not graph of the tree, and then it's gonna be again O of n, so the time complexity of n. Okay, let me start programming this one. So I'll have this function pr private void parents, and then I'll have the tree node, and then I'll have tree node target. Generally, having this target is optimization, and I have hash map for the tree node, and I'll call it again parents. And what I do there is to check uh, if node is equal null, I'll just return. If node equals target, I also gonna return. And then if node left not equals null, I'm gonna do the following. I'm gonna put parents put node dot left, and then node. Then I'll do DFS do parents node dot left target, then parents. And I'll do the same for the node dot right not equal null. I'll do the parents put node dot right node, and then I'll call parents node dot right target parents, and then I'll create a function. So initially I'll save the hash map tree node then parents equals new hash map, and then I'll do parents root target, and then parents, and then I'll do this private void find node distance k. So for the find node distance k, I need three node. I need three node from where we are coming to. I need to have this parents mapping, and then I'll need to have this level k or distance, and then I'll have this integer real list integer accumulator, and then I'll do the following. So here I'm gonna create list integer accumulator equals new array list, and then I'll go find nodes distance k, and they pass k, and then pass target, and then from null, and then parents, and then accumulator, and then I need to return accumulator. For the tree node, so I check here if node equals null, I just return. If k is equal 0, I need just to add accumulator.add node.val, then return. Then I need to basically check if node left not equal from, I'll call find node distance k, and then I decrement the distance. I go for the node left. I go from current node and have parents and have accumulator, and do the same if node dot right not equals from. It's kind of analogy. It's similar to the DFS with a visited array, visited nodes array. Yep, something like that. So I'll call find the nodes distance k minus 1 node dot right node parents accumulator. And for the last one, if let's say we have three node dot parent equals parents dot get for the current node. If parent not null, I'll do the following, and parent not equal from, I'll call find node distance k minus 1, and then for the parent, and from node, and then parents array, parents hash map, and then accumulator, and then I'll return it, and that's it. Let's check it. Find the node distance k. Do we have 5 parameters? Okay, distance k. Okay, that's it. Um, I will stop the video. Let me check what they have right here. It seems this one doesn't have okay, that's even more interesting. So they drop kind of rope through the root. That's called pass. And then for the every node, instead of saving all parents there, they just drop this rope and start the key level down. That's quite interesting. That I didn't think about that. On every kind of node upper than the current one, they hmm okay, they drop a rope and they try uh, to pull out the fish, and the fish is the target. And um, yeah, for the every node on this rope higher than the target, they manage to find the target. They start the process key level down, but they're smart enough that they do this key minus I. So in theory, it's similar to what I did, but it's more optimal in terms of space. In terms of space, it's gonna be like much less. They don't save the parent node. Yeah, that's an interesting solution. I'll try to code it as a home assignment for myself. Yeah, really interesting one. Okay, I'm gonna wrap up. Um, let's check for the memory, what they have for the memory. Map, 3 node integer. Find, hmm, okay, I'm gonna wrap up. That's gonna be it.